Perfect. All right, it's 2 o'clock Eastern time. Good morning, good afternoon, good evening. You know, the biggest challenge I would usually have when doing presentations like this is the fact that I don't exactly know where people are coming from. They could be coming from, the West Coast, which for them it's 11 o'clock in the morning. They could be in Europe, which means they're afternoon or evening. But wherever you're coming from, welcome to the Virtual PaaS Summit. It kind of feels weird saying Virtual PaaS Summit. I've been attending the PaaS Summit for the past, 13 years now. My very first one was 2007. And I kind of skipped 3 because of immigration reasons and health reasons. And it feels kind of weird doing this online, like virtual. But the thing is, everyone's at home. We're all in this lockdown, this pandemic. So I dig it. I get it. Welcome to my session, providing high availability to SQL Server on Linux. My name is Edwin Sarmiento, and a couple of things from past. You may have been aware of this. A lot of the speakers have this on their slides. So make sure you take advantage of what PaaS has to offer, local user groups, events like this, even SQL Saturdays. SQL Saturdays are now going virtual, depending on the country. Take advantage of that. They're all available online. Evaluations. I would appreciate if you could provide feedback regarding this session, because I spent quite some time preparing for this. And I also wanted to lay the foundation for this entire presentation. Again, this is providing high availability for SQL Server on Linux. I wanted to introduce myself real quick. My name is Edwin Sarmiento. I'm a Microsoft Certified Master for SQL Server and a former Microsoft Data Platform MVP. This is a little bit weird when you think about it because, well, for the previous version of SQL Server, there was really no such thing as SQL Server on Linux. And now we're talking about SQL Server on Linux plus high availability. I remember back in the early 2000s when Steve Ballmer started calling Linux as a cancer. Now we're running SQL Server on Linux. I wrote the book, The SQL Server DBA's Guide to Docker Containers. If you're keen on exploring deploying SQL Server on containers, that's a really good resource. I want to start off with 2 main assumptions. Before we get really deep into this whole session, I want to start off with 2 basic assumptions. First assumption is, number 1, you have an understanding of Windows Server Failover Cluster, which means you have worked with it in the past. You have an idea. Either you're managing, administrating, you're part of the operations team, and you're taking care of failover clustering. So that's the first assumption. The second assumption is that you have an understanding of SQL Server Always On. Forget about the marketing term. We're looking at availability groups or failover clustered instances, because both of these platforms, these 2 architecture provide high availability SQL Server. So I'm going to start off with those 2 main assumptions. Okay. You are familiar with how Windows Server Failover Clustering works, and you're familiar with how SQL Server Always On works. That's kind of like how I want to start off with this. Okay. This is not a beginner type session. That's why I kind of want to make those assumptions, because you might get lost along the way. So I want to make sure that this is kind of like the groundwork that we're laying. I want to start off with a story. Man, if this was live, if this was in person rather, we would all be in, no, not Seattle, but in Texas. But for the past couple of years, Seattle has been the city that hosts the PaaS Summit. And I remember, if you're going around Seattle, it's very easy to see every corner you'd see a Starbucks store. And if you're in North America, you're probably familiar with Starbucks. If you're somewhere in, anywhere else, you're probably familiar with it as well. And the logo is very, very familiar because, for one, they're considered to be the most valuable restaurant brand in the world. For 3 straight years, they've been voted as the most valuable restaurant brand in the world. In fact, they wanted to be the McDonald's of coffee shops. So when you think about that, not just in Seattle, you're looking at places or countries in Asia Pacific and Europe, all over. You would see a Starbucks store in airports, in big cities even. And what I find really interesting was 3 years ago when I visited Sydney, and Sydney in Australia it's a big city. It's not, it's not your typical city. It's interesting to find that, in a city as big as Sydney, there was only one Starbucks store in that city. And I find it interesting because, again, for a company like Starbucks, who have been very aggressive, in fact, in early 2008, when they started to start stores or shops or coffee stores in Australia, they were very, very aggressive. And a couple of years later, they started pulling back. In fact, these pictures that you're seeing here are news items from when Starbucks started pulling back and closing down stores. At first, I didn't believe it because, again, it's Starbucks. It's well known all around the world. Why is Starbucks pulling back on having these stores in Sydney or in Australia in general? And not to diminish my friends from down under, as what my Australian friends would say, they love coffee. They love coffee. And so why is it that a company like Starbucks, who specializes in coffee, couldn't get into the market? That's a big question that I asked when I got there. And again, Australian coffee, I'll just say it out loud, Australian coffee is way better than North American coffee, okay? And this got me into thinking about how a company like Starbucks would do something and assume that something would work. Because just because something works doesn't mean it always will. They took what they learned from operating and managing Starbucks stores in North America and brought it to Australia, and not realizing there's a totally different culture, there's a totally different way of thinking when it comes to coffee in Australia. And similarly, when we think about how that applies to what we do as SQL Server DBAs, we might think, wait, didn't Microsoft say it's the same SQL Server? Didn't Microsoft say, it's the same everything? We're running on a platform abstraction layer. And so wouldn't it work? And similar to that story that Starbucks had in Australia, same company, different country, I also was reminded of another company, Target. They were very, very aggressive coming to Canada back in 2011, I think. A couple of years later, they closed down. Just because it worked in the United States doesn't mean it will work in Canada. And similarly with Starbucks, just because it worked in North America doesn't mean it will work anywhere, okay? Why am I even pointing this out? It's because of the fact that when we think about, the marketing push that Microsoft had when they started promoting SQL Server on Linux. In fact, this was a very familiar logo from the late 2016 up to early 2017 when Microsoft was really pushing Project Helsinki. I remember Project Helsinki, and it's just the code name for SQL Server on Linux. And with all the documentation, with all the marketing push, they would tell you, look, it's the same SQL Server that we've known for ages. It's just running on a different operating system. They literally took SQL Server, created a platform abstraction layer, and ported it to Linux. It's one of the reasons why it didn't take a lot of effort to rewrite everything from scratch, because everything's abstracted. But here's the same thing though, with again, I am not trying to bash the marketing folks at Microsoft, but it's just one way of getting people to adopt the technology. It may be the same SQL Server. It may be the same database engine. It may be the same user experience with SQL Server Management Studio, the commands and all, but it's still a different operating system. And that's one thing to really think about when you're looking at deploying SQL Server on Linux. Although you can apply the same principles when you're looking at how SQL Server works and how the operating system functions, you can still use the same principles, just not the same technology. And that's kind of like the gist of this whole presentation, is to show you the differences between Windows and Linux as far as high availability is concerned. Okay. Here's the thing though. Just because you know Windows HA doesn't mean Linux HA will be easy. In fact, I had a client about two and a half years ago reached out to me, and their big Linux shop, top to bottom, the only Microsoft deployments that they have are their Active Directory, domain controllers, and SQL Server. And they asked me, hey, we want to move our SQL Server to Linux because Microsoft is really pushing hard on deploying SQL Server on Linux, and we want it to be highly available. And don't worry about the Linux stuff. We got our entire staff. They're all Linux engineers. And there was only one question that I asked that got them to really reconsider. And I said, do any of your engineers know Pacemaker like the back of their hands? And that was all the question that they needed to answer to push back and just deploy SQL Server availability groups on Windows. Again, just because you know Windows HA, just because you know Windows Server Failover Clustering or how availability groups or failover clustered instances work, doesn't mean moving to Linux will be easy. And this is, again, the focus of this presentation, how to provide high availability to your SQL Server databases on Linux. So let's look at these two. Let's look at SQL Server and then high availability from both the point of view of Windows and the point of view of Linux. Let's start off with high availability on a Windows Server Failover Cluster. I want to reference a very familiar infrastructure that's been there since SQL Server 7. Windows Server Failover Cluster running a SQL Server Failover Clustered instance, the very common two-node failover cluster. You have one SQL Server instance, databases are stored in your underlying storage subsystem, and then client applications will connect to the database using a virtual network name. And it doesn't matter which of these nodes are running is running SQL Server, they will automatically get redirected to whoever the node running, or whichever node is running the SQL Server engine. Enter SQL Server 2012, and Microsoft introduced always-on availability groups, where you can now have multiple copies of your databases running on different nodes, but we only one primary replica. And this is where you can have a cluster with no shared storage. And in addition to that, you have multiple copies of your database instead of one copy of the database. Here's the thing, though. What makes a SQL Server highly available and what allows availability of databases is what it is sitting on top of, and it's the Windows Server Failover Cluster. If you've been working with Windows Server Failover Clustering, this is something that you're very familiar with. And I'm going to use a very generic term for this. It's called the Cluster Resource Manager. Yes, we know it as a failover cluster. We know it as Windows Server Failover Clustering, or back in the days, Microsoft Clustering Services. But the generic name for it is Cluster Resource Manager. And there are different platforms out there that provide the functionality of a Cluster Resource Manager. Veritas, InfoScale Availability, they have their own product. When I was still a data center engineer, it was one of the products that I supported for providing high availability to applications. Let's have a look at that Cluster Resource Manager and what it really does. It's a software that runs on all of the nodes in the cluster, and it's responsible for maintaining a consistent image of the cluster. Meaning, like I mentioned in the previous slide, you can have 3, 4, or more nodes in the cluster. And client applications connecting to the database, they don't really care which node is running the SQL Server service. Or let's be generic, whichever node is running the app. If one of the nodes fail, or if one node, the one that's currently running the the app. If that fails, the cluster will then move the workload over to any of the available nodes. Now, the client application doesn't need to know that, oh, it's no longer running on server A, it's now running on server B. And that is the job of the cluster resource manager. Its goal is to maintain a consistent image of the cluster. In addition to that, it's the cluster resource manager that is responsible for high availability, automatic failover, failure detection, and everything else that the cluster resource manager does. It's one of those things where I kind of reacted negatively when Microsoft announced back in 2017 that they're supporting what is called a clusterless availability group. Why is that? It's a little bit contradictory, come to think of it, because you're telling me that the name of this platform is availability group, but there is no cluster. So how can a clusterless availability group be highly available? It's not. Now, I want you to really think about that for a second, because a clusterless availability group is not highly available. It is only through a cluster resource manager that you can achieve a high availability for your SQL Server databases, be it for availability groups or failover clustered instances. Okay. What is the goal? And as I mentioned earlier, the goal of running a cluster resource manager and putting SQL Server on top of it is to provide high availability and fault tolerance. Okay. With clusterless availability groups, that's mostly for read scale of your read-only workloads or for disaster recovery. But it's not, and again, I want to emphasize that, it is not for high availability. The only way to provide high availability to your SQL Server databases is if it was running, or if they were running on top of a cluster resource manager, which in our case for Windows is the Windows Server Failover Clustering, and for Linux is Pacemaker. And this is where I start talking about what Linux high availability is. Now, I just want to pause real quick for a few questions if we have them in the queue.
We haven't received any, Edwin.
Okay, perfect. Which means either we are doing great as far as, the first part, or people are still figuring out how to type those questions. Anyway, we've talked about Windows. Now let's talk about Linux. With Linux, there is this cluster resource manager called Pacemaker. Okay. This is kind of like the very common, most common cluster resource manager out there. It's an open source platform, but companies like Red Hat Enterprise Linux and SUSE Linux Enterprise Server, they came up with their own package and included it in their own distribution. Similarly, though, like I said, the way it works is no different from how failover clustering works. It's the same concept underneath, where it provides high availability to an app, or in this case, SQL Server, through multiple machines running at the same time and allowing the workload to run on one node at any given point in time. If that node becomes unavailable, probably due to power failure, hardware failure, or I don't know, a bug in the system, which never happens, the cluster resource manager will trigger a failover and keep the application running on the other node. That is Linux Pacemaker. Okay. You would rarely see documentation out there from Microsoft on how the cluster service works. This is similar in context, because what we're going to do here is we're going to pull back, open the hood of the car, and see how the Pacemaker daemon, or Pacemaker service or stack works by looking at every single one of these components. Sit tight. We're going to dive deep. Let's start off with a cluster information base. What is this? You can think of the cluster information base as the cluster database in a Windows Server Failover Cluster. The database that has all of the information about your failover cluster. Number of nodes, number of resources, virtual IP address, virtual network name. Because this is Linux, there is no Windows registry to store this information in. In Windows, the cluster database is stored on the cluster registry Hive on every single node of the cluster. In Linux, Pacemaker's cluster information base is stored as an XML file and loaded in memory. Okay, and like I said earlier, much like the cluster database, this exists on every single node in the cluster. But unlike in Windows, where the copies of the cluster database on every single node gets updated simultaneously as changes are happening in the cluster, in Pacemaker, you only have one master copy of the cluster information base. Everything else is a replica, which means the changes will be sent to one node, which is called the designated coordinator, and that node will have a master copy of the cluster information base. Now, I already mentioned designated coordinator. Think of the designated coordinator in Linux Pacemaker as the node in the Windows Server Failover Cluster that is running the cluster core resources. Okay, this is kind of like the boss. He's checking, hey, can you report back to me on the status of your cluster resources, and you report back to me on the health of all the resources running on your node. And the designated coordinator is the one responsible for keeping track of that. The changes are stored in the cluster information base and are replicated on the other node's copy of their own cluster information base. The second one is the policy engine. From the name itself, it's taking care of policies defined for the resources in the Pacemaker cluster. I kind of refer to the policy engine like the cop that has this radar in the freeway where they're like shooting whoever's overspeeding. And when the radar picks you up, like you get pulled over and then you get a ticket. The policy engine is monitoring for the resources running on top of the cluster, and it's responsible for checking, hey, is this particular resource meeting the threshold that this specific resource agent, which we'll talk about later, defined? If it is going beyond the threshold, this is what I will be doing. Again, kind of like the cop who would pull you over if you're overspeeding and will give you a ticket. That's a policy engine. And then you have Stoneth. And this is, the funny thing about naming. The people who are actually thinking about these namings, they're really creative. Stoneth literally means shoot the other node in the head. So Stoneth is a fencing mechanism. I kind of think of it as, giving somebody a timeout. When there's a misbehaving kid, you're going to get a timeout. The idea behind Stoneth is if a node starts misbehaving, and again, from the name itself, it will get shot in the head so that it doesn't affect the availability of the cluster. Again, when one of the nodes starts misbehaving, Stoneth will then fence that node so as not to interfere with availability or cause any issues with availability of the resources in the cluster. Now, all of these components talk to each other, and they're relaying their messages to a cluster resource management daemon. I kind of think of the cluster resource management daemon as a switchboard. Although I kind of like to think about, the telephone operator back in those days, and you'd make an international phone call, and you would dial the operator, and they would connect you to the switchboard so that you can talk to whoever's on the other end of the line when you make an overseas phone call. The job of the cluster resource management daemon is basically that. They will send all of their information to the CRMD, and the CRMD will then talk to other CRMDs in other nodes and then send those information back. There's this back and forth communication between the CRMD on node 1 and the CRMD on node 2. Why? Well, keep in mind, every single one of the nodes will have to look at the messages and the information being passed to and from so that the cluster can decide, hey, Can I fail over to node 2? Looks like that guy's misbehaving. I don't think it's a good idea to fail over to node 2. Okay. Every single one of the nodes in your failover cluster will have these components. And they're passing back and forth messages and information that would determine whether or not the cluster still needs to come online, or the cluster will have to protect itself, and all the other mechanisms that make high availability possible for the cluster. There are other components, and we'll talk about other stuff like, for instance, the local resource management daemon. From the name itself, the local resource management daemon is the one responsible for the resource or the cluster resources running on that specific node. I kind of like to think of this as the one responsible for checking if this node is the primary replicate in AG or not. Okay. Now, in order for the local resource management daemon or manager daemon to do its job, it has to talk to what is called a resource agent. Resource agents are kind of like the cluster resource DLLs in Windows Server Failover Cluster. It's the resource agents that wrap the functionality of the resource running on top of the cluster. And I'll explain a little bit of that later. But the idea behind this is it is the local resource manager daemon that talks to the resource agent, and the resource agent is the one that talks to the app or the cluster resource. In our case, it's SQL Server. There are other two components in here, like the cluster, consensus cluster membership. This is the one responsible for checking, hey, is this guy healthy? If it's not, let's remove it from the cluster membership. If it's back online, let's add it back. And then the heartbeat, which is the messaging mechanism, kind of like how heartbeating works in Windows Server Failover Cluster. These two components, the CCM and the heartbeat, are the ones responsible for or rather they're combined in one component, which is now called CoroSync. This is, again, implementing both the cluster membership and the messaging that gets sent across all of the nodes in the cluster. And similarly, CoroSync will talk to the cluster resource management daemon, which would then talk to the other cluster resource management daemon on the other nodes, and exchange those information in order for the cluster to make those decisions to bring the resource online, keep the cluster on one of the node, and so on and so forth. Okay. Do we have any questions at this point, Sanjeev?
No, we don't.
Wow. That's really cool. And we're also good on time. So I want to do a quick comparison. Like I said, I just took you deep into how Pacemaker works under the covers. And like I said, you would barely, there isn't much information about how Windows Server Failover Clustering works with that level of detail. The thing is, now that you have an understanding of how Linux Pacemaker works and how Windows Server Failover Clustering works, let's look at how we could use these differences in order to understand how does SQL Server behave when you're running it on Windows versus when you're running it on Linux as far as high availability is concerned. Okay, we'll look at these two comparisons in terms of three differences. The first one is what I call communication. What do I mean by communication? There's this, what I call the two-way communication on between SQL Server and Windows Server Failover Cluster versus one-way communication with Linux Pacemaker. What do I mean by that? Because failover clustering is the one responsible for providing high availability, SQL Server needs to talk to the failover cluster. And the cluster can talk to the SQL Server database engine through what is known as the cluster resource DLL. Those interactions are what make SQL Server availability groups and failover clustered instances highly available on Windows. Why? If you are on a Windows Server Failover Cluster and you decide, hey, I want to do a failover of my availability group from node 1 to node 2 because we're performing maintenance, we're installing patches, you could right-click on an availability group and do failover, or you can run the alter availability group failover command from inside T-SQL. What that does is SQL Server will communicate the message to the Windows Server Failover Cluster using the cluster resource DLL, and the failover cluster will be the one to initiate the failover. That's called two-way. You talk to SQL Server will talk back to the Windows Server Failover Cluster and initiate the action. Okay. With Linux, only Pacemaker can talk to SQL Server. In fact, when you right-click on an availability group in SQL Server on Linux, the failover option is grayed out. You cannot right-click failover or run an alter availability group failover from inside SQL Server, which means you can only failover an availability group through Pacemaker. And that's where what I call the two-way versus one-way communication. Another example of that is when, let's say, you want to switch from synchronous to asynchronous. In Windows Server Failover Cluster, I can switch from synchronous commit to asynchronous commit, from manual failover to automatic failover. And the manual and automatic failover is a change in the failover cluster configuration where you're adding or removing the available group replica from the possible owners list. You can't do that with Linux. You either configure the replica from within Pacemaker, but not from inside SQL Server. So you really need to make those decisions as early as possible on how you want the cluster to control how SQL Server gets failover, or how the cluster behaves in terms of which node or which replica becomes the primary depending on the situation. The second one is what I call coupling. There's this the concept of tight versus loose coupling. And like I said in the previous slide, one of those examples is I want to change my failover mode from automatic to manual. In Windows, that gets passed back to the failover cluster through the cluster resource DLL. In Linux, I can change manual, automatic, and nothing happens on a Pacemaker cluster. You have to explicitly do that from Pacemaker in itself. So you're actually doing two things. You're doing it from inside SQL Server, and at the same time, you have to do it from within Pacemaker in order for those changes to take effect. Of course, this is very self-explanatory when we talk about Windows integration, because SQL Server has been built with Windows in mind. So a lot of the Windows integration features are there ever since the beginning. Because of this, there's also this tight and loose integration between SQL Server always on Windows versus SQL Server always on Linux. One key difference between Linux and Windows is just the fact that you could use Windows Active Directory accounts for configuring available groups. We're looking at available group endpoints. You can use domain accounts to secure your available group endpoints, whereas in Linux, you could only use certificates, which is kind of interesting because when 2017 was released, one of the sections in the documentation actually talks about how you could configure certificates. And there's this, in future releases, they may integrate Windows authentication with endpoint security. Now, keep in mind, you could join a Linux machine to an Active Directory domain, no question about that. But I'm more concerned about protecting the available group endpoint using Active Directory domain accounts. I'm still hoping that Microsoft would come up with something within the next version, because it's a pain in the neck. Okay. Before I go into the demo, again, I want to pause for a couple of questions that we do have. And the demo will be focusing on configuring high availability for SQL Server on Linux with Pacemaker. Do we have any questions in the queue, Sanjit?
Yes, we have one. Does the loose coupling make the cluster more fault tolerant?
Very interesting question. So the question was, does loose or tight coupling make a SQL Server more fault tolerant? And the answer to that is actually yes. Because when you really do think about it, SQL Server and Windows are talking to each other. Kind of like SQL Server and Windows having this heartbeat conversations, in addition to nodes in the failover cluster having this heartbeat conversations as well. So anything that's going on within SQL Server would trigger a policy to the Windows Server Failover Cluster via this cluster resource DLL. Okay. You do have something like that with Linux. It's just that the amount of time it takes to do a failover will be a lot longer on Linux than it would be on Windows. And in the configuration, I'll show you why. But again, this is also one of those reasons where if you're really looking at higher availability when it comes to availability groups or even failover clustered instance between Windows and Linux, this is one of those things that you have to consider. If it's a microsecond difference, then it's huge. I would rather go with Windows than Linux. Okay. Any other question?
Okay, that's all we have. Thank you.
So this is not a walk in the park. Let me paint a really good picture here. It's not a walk in the park. It's also one of the reasons why I recorded a video demo. I can do it, but then every once in a while there's glitches, and earlier we were having some issues with audio sync delays. I want to give you an overview of what I'm going to do. I'm going to build a 3 replica availability group running on a Linux Linux Pacemaker cluster. Okay. Yeah, 1 primary, 2 secondaries. Also, I've already built the availability group. Yes. See, here's the thing though. That's one of the reasons I mentioned earlier. If you really want your availability group to be highly available, you need to have an underlying cluster resource manager. I already have an availability group and it's running. It's not highly available, but it's running, all right? So I've already done the legwork to configure availability group because, like I said, it's a pain in the neck. This is kind of like how we would go about configuring Linux Pacemaker. And by the way, I haven't even included how to configure availability groups because that would entail creating certificates, exchanging certificates between the availability group replicas, mapping the certificates to login, and so on and so forth. It's not a walk in the park. So we would start off with having an available group already working. The databases are already in the availability group, replicas and all of that with the listener name even. It's up and running, but we don't have a cluster resource manager yet. This is what I'm going to be doing. And since you're at home, take a screenshot because I'm going to walk you through this. Now, this is just the first part. We will configure Linux Pacemaker. We'll install the package, configure it. And once it is configured, we will then have to configure always on available group as a resource on Pacemaker. And like I said, since you're at home, take a screenshot. This will be the workflow process that we will go through. Okay. Let me hop onto my environment real quick. And what you're seeing here is an availability group with 3 replicas running on 3 Linux machines. By the way, these are all running Windows SQL Server 2019. Okay, and if you look at the availability group, I already have the listener name, I already have the virtual IP address, and everything's up and running. However, and this is one of those examples where I mentioned earlier about the tight versus the loose coupling. The listener name is already available, and if you look at the state_desk column below, it says it's online. Well, from the point of view of SQL Server, the listener name is online, but then because it's not exposed, meaning there's no cluster resource manager to expose the listener name, I can't connect to it. That's why a simple ping test doesn't work. In fact, even if I connect to the SQL Server instance using the listener name, I won't be able to. Okay, so that's one thing Plus, going back to the tight versus the loose coupling, in Windows, when you create an available group listener name, SQL Server will talk to the failover cluster, and the failover cluster will create two things in addition to the available group. It will create a listener name with a corresponding virtual IP address, just like what you're seeing here, okay? In Linux, it doesn't, okay? Like I said, even though the listener name is there, SQL Server says it is online. The fact that it's not exposed to the network through through a cluster resource, I can't connect to it, even though SQL Server says I can, and it's online. This is one of those examples of the tight versus loose coupling. And in addition to this, I have to manually add the listener name record to my DNS server. Unlike with Windows, given the right permissions, I can create a virtual network name in the DNS just by creating my available group listener name. And that would also create the corresponding virtual IP address, of course, in addition to the virtual computer object in Active Directory. Okay, so again, just because I have an availability group doesn't mean it's highly available at this point, because we don't have a cluster resource manager. Okay, so let's go ahead and configure a cluster resource manager. The steps that I'm going to outline in here are exactly what you've seen in the slide. Okay, I'm just going to walk you through the different steps, and I'm also going to explain the different commands that I used for this. I connected to my Linux machines using SSH, and this command is simply installing Pacemaker, which is the CRM stack, PCS, which is the management component for managing Pacemaker, fence-agents-all is where Stoneth is a part of, and then we have resource agents. This is the local resource manager daemon that will talk to the SQL Server high availability resource agent responsible for talking to the availability group. Okay. Oh, by the way, I'm running CentOS Linux. Not Ubuntu, nothing against Ubuntu. I just don't prefer running Ubuntu, and Ubuntu is for developers. These are for real people. So I'm running this command. This is step number one. We want to install Pacemaker packages on all of our Linux machines. And I just had this color coded so I can differentiate which one is node 1, which one is node 2, and which one is node 3. SQL Server has already been installed. In fact, the SQL Server high availability resource is also already installed. That's why I managed to configure availability group on top of this, even without Pacemaker. Once the packages have been installed, the next step would be to start the daemon. In this case, the PCSD daemon, or the management component that we would be using for configuring Pacemaker. So we're going to do that. We're going to configure this. It's like on Windows, it's like configuring a Windows service to automatically start, and I have to do it on all nodes in my cluster. The third one will be to configure the Linux firewall. Not a good, you see a lot of documentation out there where they will tell you, look, disable this Linux firewall. Even on Windows, people would say that. Don't, please, don't. Okay. Security best practice, make sure that you're configuring your Linux firewall properly, or even on Windows. Okay. This is one of those examples between tight and loose coupling with Windows. I can create an Active Directory group policy object for this, deploy it on the Windows machines, and then the group policy object will then configure traffic between my cluster nodes. Whereas in here, I would have to manually configure them on all of my nodes, which is, again, something that you really have to keep track of, especially for change management purposes. Once those configuration settings, and by the way, that command is simply allowing the high availability daemon to pass through the Linux firewall. Keep saying Windows. You can be more explicit and define the specific port numbers, whether it's UDP or TCP. And what you're seeing below is specifying the individual port numbers. I kind of like using just high dash availabilities, and that would take care of all of the port numbers, allowing the traffic to and from the nodes. And once firewall changes have been configured, we need to reload the firewall so that those changes do take effect. And again, these would all have to be done on all of the nodes in my Linux cluster. Next, after that, we're going to look at forcing the pacemaker and ChorusSync daemon to start on boot. Again, similar to how you would configure a Windows service to start on or automatically start on reboot. This is just basically it. Excuse me. Now, once we've done that, and keep in mind, we haven't even done anything on the cluster yet. We are just doing the prep work to get all of these things up and running, okay? The next one will be to assign a password to an account named HA cluster. Now, here's the thing though. When you install the Pacemaker package, it also creates a user account named HA cluster, and it will create the account on all of the nodes that you've installed the Pacemaker packages on. This is no different from you creating a local Windows account, right? Now you might be thinking, why do we need that? No, again, there is no Active Directory. There is no centralized repository of user accounts. So you have to do it on all of these nodes. And this account is used primarily for managing the cluster. It's like doing impersonation on managing the cluster. You're kind of fooling Linux that, hey, I'm logging into the cluster using this account, and therefore these are the credentials that I'm going to use. The key thing here is every time you're making changes to an account, it has to be done on all three nodes or all of the nodes in your Pacemaker cluster, because one wrong account on one of the nodes, then some of the functionalities won't work, okay? Step number 6 is we want to set up authentication between nodes. You can think of this as running the failover cluster validation wizard in Windows, or running the test-cluster PowerShell commandlet, where you're passing the names of the nodes and running failover cluster validation. Now, in this case, one thing that's different between Windows and Linux is on Windows, you can do a validation, which means you know whether or not something would work. Here, we're not doing any validation at all. All we're simply doing is running cluster authentication. That's where you see PCS cluster auth. You want to check if I can use the HA cluster account, whether I'm coming from node 1, node 2, or node 3, that I can manage the cluster. That's it. No cluster validation, right? That's all this is doing. And it's setting that up in preparation for you building the cluster. So you're seeing I'm passing the node names. And by the way, I'm not just using host names. I'm using fully qualified domain names, mainly because I'm using a DNS server in the background, which is easier to maintain rather than updating host files. So I'm going to run this. And just like failover cluster validation, I can run this on any server that I want to join as nodes in my cluster. So I'm running it on node 1. And this would prompt me for password, connect to all of those nodes that I defined in the command, pass the credential HA cluster, and then check if I can connect. Okay. Next is we will create the Linux cluster. And if you look at the command here, I'm simply passing the host names, the machine names, and passing running the PCS cluster setup. Linux HA Clus is the name of my cluster. This is similar in context to running the create cluster wizard in Windows Server Failover Cluster, or running the new -cluster PowerShell commandlet and passing the cluster name, which is kind of like the cluster name object for Windows Server Failover Cluster. And you can run this on just one of those nodes. And if you see in the background, it is coordinating with the other nodes, and you'd see stuff like Pacemaker remote auth key. The authentication and the communication between the nodes is done via certificates, and Pacemaker takes care of that in the background. That's why you see restarting PCSD on the nodes in order to reload the certificates. Remember the PCS cluster auth command that we ran earlier? That is not just communicating, it's also generating the certificates in order for the communication to happen between those nodes. Man, step number 7, and we just created our cluster, but we're not done yet. Okay, we're not done yet. After creating the cluster, we need to start the daemon on all nodes. Right. Keep in mind, just like in Windows Server Failover Cluster, you're running a service across all of the nodes, so they all have to be running. Next, this is where we configure fencing. Now, fencing is implemented commonly by use of either shared storage or a hardware fencing mechanism, like a power distribution unit or network device, or in a virtualization environment, you could use VMware's fencing agents. There is no supported way for configuring fencing agents for Hyper-V or cloud stuff. So this is not something that I would recommend in a production environment. This is just, again, used to demonstrate the fact that you could disable Stoneth in this case. Again, not recommended in production. I would highly recommend running high availability on physical machines, and then use a hardware fencing agent, or run it on VMware and use the VMware fencing agents for Linux. The next one is configuring resource level policies. Now, this is the thing about this is the way Windows and Linux differ when it comes to handling resources is quite different. If you've seen how Windows Server Failover Cluster works, the resources are managed through what is called resource level policies. I kind of refer to them as resource level policies because on Windows, let's say you have a listener name and a virtual IP address. If all of a sudden the listener name fails for whatever reason, the cluster will first attempt to restart that resource on the current node that it is running on. And if that fails, that's the only time that it would attempt to fail over on any of the nodes. Because why would I fail over an entire resource group if only the network name is misbehaving? Besides, the client application already has the DNS information stored in the DNS client cache. So why bother? Why bother taking an outage for something that could be avoided? This is what it is. PCS property set start-failure-is-fatal equal to false. This is allowing the resource agent, in this case, the resource agent responsible for availability group, to take care of that instead of having the cluster automatically fail over an entire resource just because one of the resources isn't working. Okay, so let's do that. Let's configure this particular property to configure the resource level policies. And it has to be done in all of the nodes in the Linux Pacemaker cluster. Now, this is a little bit it's a little bit confusing for some people. When I started working on this a couple of years ago, people were asking, so why do I need this? Why do I need to create a SQL Server login for Pacemaker? Keep in mind though, in Windows Server Failover Cluster, if the cluster needs to trigger, if the cluster needs to trigger a failover for the availability group, it's the cluster resource DLL that does that. It's the reason why you are granting the NT authority local system account permissions on every single SQL Server instance that is participating in an availability group. The concept is similar. Here, it's Pacemaker that is going to trigger an automatic failover. But in order for this to be able to do that from within SQL Server, it needs to be able to log in and execute stuff like alter availability group failover. And these are the things that that Pacemaker needs in order to perform those failover. Keep in mind, you cannot failover an available group from within SQL Server. It's the cluster resource manager taking care of that for you. That's why we need this login. So we're creating a login specifically for Pacemaker, and we're granting alter control view definition on AG as well as view server state for the specific login. And we need to do this on all of the replicas in the AG, not just the primary replica, but for all. Because again, the cluster resource manager is the one taking care of the failover, so it has to be able to log in to that specific replica and then, trigger failover. So that's basically this. We're creating that login. And by the way, this login is what the SQL Server High Availability resource uses to connect to SQL Server. Keep in mind, the local resource manager is taking care of the resource, but in order for the local resource manager to talk to SQL Server, which is the resource, it has to have a resource agent. The resource agent is using this specific login in order to connect to the SQL Server instance and then issue commands like alter availability. Next, after creating that login, we're going to save that credential, the login and password of that SQL Server login, to a file. We will call the file passwd, and we will store it inside the var opt msql secrets directory. Okay, this information, like I said, is what the cluster resource agent would use to connect to SQL Server and then issue those commands. So it has to be stored on every single replica in the availability group. Here we're simply changing the ownership of the file. We want to make sure that only the root owns the file. At the same time, only the root has read-only and only read-only access to the file. Anybody who has access to the file can modify it, and therefore Pacemaker will no longer be able to perform connecting to the SQL Server instance and issuing commands like alter availability group failover. Whew. Before we move on to the next part of it, again, this is just the first part. Before we move on to the second part of this, are there any questions on the entire process?
No questions, thank you.
Okay, no questions. By the way, I'm going to be providing these the commands and the scripts later. But I'm just walking you through the different steps and the process in order to configure Linux Pacemaker and eventually registering the available group resource inside Pacemaker. Now let's go ahead and configure the available group resource on Pacemaker. We've done just the first part, which is setting up our Linux Pacemaker and configuring it in preparation for registering the resource, the available group resource on the cluster resource manager. We've done so much work, and yet available group is still not highly available. So let's go through the sequence of steps. First, we will create a resource. I want to, well, let's run this first, and then I'll explain the command in more detail as we look at the different parameters. PCS resource create is the command. We will create a cluster resource on top of Pacemaker, and we will create it Linux _ SQL AG. This is the name of your availability group. Now, it doesn't have to be the same name as your availability group. I just want to keep things consistent. It could be anything. Okay. OCF : MSSQL : AG. This references the Open Cluster framework, and this is the name of the resource agent that's created specifically for SQL Server. In fact, when you install SQL Server on Linux, if you want to configure high availability, this is one of the packages that you have to install. We are telling Linux Pacemaker, hey, if you want to control this resource, use this resource agent. Okay. AG _ name is the parameter that we're passing to the resource agent to identify which AG this is. And in this case, we're going to name it Linux _ SQL AG. Now, this one has to be named the same as your availability group. Master is the parameter that we're going to use because this is kind of like a master-slave configuration. In Linux, there are different ways to configure high availability applications, but this is not a network load balance cluster, much like your web applications. This is an availability group where you have one primary and multiple secondaries. You cannot have multiple primaries. And so what we're telling the Pacemaker cluster, hey, I want you to create a resource where we have one master and multiple slaves. So this is what the command does. We're creating this, and it's a pretty straightforward thing. Again, going back to how this is in Windows, you just create the availability group. SQL Server will talk to the Windows Server Failover Cluster through the cluster resource DLL, and the cluster resource DLL will then tell the failover cluster, hey, I want you to create this resource group for me, and I want you to add this resource inside the resource group. Here, you have to manually do it outside of SQL Server. Again, the tight versus the loose coupling thing. The next step is creating a virtual IP address resource for the available group listener name. Now, here's the thing, though. Unlike in Windows Server Failover Cluster, you're providing both the listener name and the IP address. In Pacemaker, you don't really need the virtual network name. You only need the virtual IP address. And that's one of the reasons why I've already defined the DNS name on my DNS server, because Pacemaker is not going to do that for you. In fact, the only resource that would exist inside Pacemaker is the virtual IP address. Okay, so the name resolution happens outside. Unlike in Windows Server Failover Cluster, both the listener name, which is the virtual network name, and the virtual IP address exists inside the failover cluster. So let's go ahead and do that. We'll create the listener resource named AG listener _ VIP. Again, it's a type of network address type, IP ADDR2, and this IP is the exact same IP address for your listener name with a subnet mask of 255.255.2550. Once we've created the listener name, the virtual IP address, again, I'm not creating a listener name or a network name on Pacemaker. I'm only creating a virtual IP address. Next, we're going to configure resource grouping. Now, what is this? This is a little bit different from how Windows does it. In Windows, we're looking at one resource group with multiple resources. One resource group, multiple resources. And inside that resource group, you have your AG, you have your listener name, and then you have your virtual IP address. Here, because we've configured our available group as a, kind of like a master slave configuration inside Pacemaker, we have to explicitly tell it, this is how I want you to treat the other resources in this cluster. For one, there's this thing called collocation constraint. That's why the command is PCS constraint collocation. We want to add the listener, the AG listener underscore VIP resource to the same collocation as the Linux underscore SQL AG dash master, which means wherever my available group is, I want my listener IP address should be, which makes sense, right? You don't want your available group to be on node 1 and your listener IP address to be on node 2. Don't want that. But again, difference between Windows and Linux, on Linux, you have to explicitly state that. On Windows, nope, they're all in the same resource group, and the resource group will take care of itself. Okay? If you fail over the listener name, every single one of the resources, the virtual IP address and the AG would fail over with it because it's all part of the same resource group. Here, you have to explicitly specify it. And then you're looking at the final one, although in this case, we still have like infinity with RSC role equal to master. By the way, one thing to note about that step over there with infinity is, again, because these are two separate resources that we're trying to pull together so that the cluster will move them all at the same time, these parameters make those process possible. The last one, which is step number 4, is to configure resource dependencies. Now, I find this really interesting because with Windows Failover Cluster, this is kind of like built in. What happens is that there is this concept of cluster resource dependency in Windows. What do I mean by that? The virtual network name, which is my listener name, is dependent on my virtual IP address. My availability group is dependent on my listener name, which means I won't be able to bring my listener name online if my virtual IP address is not online. In the same way, I won't be able to bring the available group online if the listener is not online. So there's this dependency. I have to explicitly configure my resource dependencies within Pacemaker. Because again, I don't want my availability group to be online, but my listener IP address isn't online yet. Okay, so what we're doing here is, let's simulate a failover, for instance. If I want to move my AG from node 1 to node 2, the process would be I would take the listener IP offline so that nobody can connect to the AG, and then I would take the AG offline. Fail it over to node 2, I would first bring the IP online and then bring the availability group online. That's the sequence of events of what the cluster needs to do when you're doing a failover. Okay, and again, we are explicitly defining that on our Pacemaker cluster. Let's have a look at the status of the cluster, just so we could see if everything is laid out and functioning the way we want it to. We're going to run the PCS, PCS cluster status. And I want to point out a couple of things in the configuration. By the way, they're all command line. A couple of things to point out. There, let's start with this. Linux HA Clus is the name of our Pacemaker cluster. You would see current DC. I mentioned something about designated coordinator. This is kind of like the boss. Linux SQL HA02 is the boss, which means he's making the decisions, which means this machine has a copy of the cluster information base, and he's the one making decisions as to how the health is, how the failover would work, and so on and so forth. And that's Linux SQL HA02, not necessarily Linux SQL HA01, which is the primary replica of our AG. Okay, we have 3 nodes configured, 4 resource configured. Online, we have all 3 machines online. And we have this list of resources that we just configured: master/slave set, Linux SQL AG-master, and the name of the resource that we assign it to. Master is Linux SQL HA01. keep in mind, we did not define this. We did not say, hey, I want you to use Linux SQL HA01 as your master. That was taken from the local resource manager talking to the SQL Server HA resource agent, diving into the availability group, and then seeing, hey, Linux SQL HA01 is the primary replica. Let's use this as our master. And then you have your slaves, which are your 2 nodes, and then your listener, and then the state, which is started. You also have this these different statuses from the status of your daemons or your services. Core sync and pacemakers are active but not disabled. So we could then configure these 2 services to start on boot, which means, you know, automatically start when the machines start. Okay. And there you got active and enabled for both, for core sync, pacemaker, and PCSD. Now, here's the test. Unlike earlier where your ping test does not get any response, now because the virtual IP address associated with the listener name is now exposed to the cluster using Pacemaker, I can now even connect to my availability group or the primary replica using the listener name, which again, before we configured Pacemaker and registered the available group resource, we were not able to do so. Now we can. Okay. Let's move ahead and connect to it using the listener name. And there you go. In fact, you could even see the properties of this. The instance name is now Linux SQL HA01, which is our current primary. Excuse me. And part of that also is checking whether or not this works. Very simple test. You could initiate a failover by killing one of the nodes, because again, we can't do failover from within SQL Server. It has to be done via Pacemaker. So simple test, just kill the node, run a shutdown command on the node and see how that thing would work. So right now my primary is Linux SQL HA01. I can, like I said, I can kill Linux SQL HA01, run a shutdown command on the Linux machine, and then do a quick failover to check. And again, part of the test is just run a continuous ping test to see. Do we have any questions in the queue before we wrap up?
Yes, we do.
Sure.
The first one is, with all these steps, are people using this configuration in production? It seems a lot.
That is a really great question. And I'll answer that in a few seconds. Do we have other questions? Because I have that answered that question in the slide.
The other one is, can the scripts and instructions be added in the presentation materials?
Yes, they will be. So if you look at the high availability option, I just killed the primary replica. You see the request timed out thing. Pacemaker detected that Linux SQL HA01 is offline, automatically did a failover, and you'd see that it does take quite a while compared to how Windows Server Failover Clustering works, but now it's back up and running. Okay. And you would see even that when you look at the availability group, now it's currently running on Linux SQL HA03 as the new primary replica. And even this, if you look at the master and the slaves, they are now changed as a side effect of one of the nodes becoming unavailable and Pacemaker taking care of the failover. So for the question on if I can include the resources, the scripts, and the step-by-step, I actually have written a 5-part series article on msqltips.com on this. I wrote this a couple of years ago. While the steps are based off of SQL Server 2017, it works on SQL Server 2019. The scripts are there, explanations are there, the step-by-step process with screenshots are all there for you to use and practice. I want to answer that question earlier that somebody posted with a final food for thought. And it's this: before you decide to deploy SQL Server on Linux Pacemaker, ask yourself this. If you were to do this on your own, how would you feel? And I know somebody was asking, hey, pretty complicated. There's a lot of moving parts, really complicated, which goes back to my story earlier about one of my customers who came up to me and said, hey, we want to deploy available groups on Linux. What do we do? And the only question I asked was, do you have anybody on your team who knows Pacemaker like the back of their hands? And if you do, then go ahead. That was more than enough reason for them not to. In fact, there were very few who would go into production with this because, number one, even Linux experts are not really comfortable with dealing with Pacemaker. Not to mention, we're looking at both SQL Server and Linux Pacemaker at the same time. So it's really not about whether I can do this. It's really all about, hey, how would I feel if I were doing this on my own and I'm sitting there and my entire infrastructure is offline because the databases are offline and I can't do anything about it. Just some food for thought for you to think about. If you're thinking about it or your boss wants you to do it, it's really more than just technology aspect. It's really all about, can you and would you? And with that, thank you very much for joining in. Unless we do have a few more questions in the queue, I'm more than happy to address them.
We don't have any others. Thank you.